Here are your video notes for Lesson 7.5, Writing and Graphing Exponential Decay Functions. And exponential growth was what we did in Lesson 7.4. We're going to compare that with exponential decay, which is what is new to you in Lesson 7.5. The nice thing about this is the equation for exponential growth, y equals a times b to the x power, is the same for exponential decay. As an example of exponential growth, let's look at a table and fill in these numbers for me. Y should be 0.75 or 75 hundredths, and then 3, 12, 48, 192, 768, 3072. We should be able to take this equation in that form, go down there, fill in the blanks, and write an equation for that table. First, we need to remember initial value is what the A stands for, and we're going to look here for the initial value, which is the value of y when x equals 0. So we're going to fill that in the first blank. We'd get that y equals 12 times something else to the x power. The second value that goes in there is called the growth factor. The growth factor is the value of b. It would go in the second blank, and we would find that by looking at when x increases by 1, what are we multiplying the y value by? To go from 3 to 12, we are multiplying by 4. We should check and see, does this work every time x goes up 1? Does y go up by multiplying by 4? And if you check with the calculator all these values through the table, you would find that you are always multiplying by 4. So our growth factor is 4, and our equation would be y equals 12 times 4 to the x power. Now if we take a look at what's going on in Lesson 7.5, exponential decay, an example of this, we're going to set up the same type table, but instead of our numbers increasing as we go down the table, our numbers are going to decrease as we go down this table. And we're going to start out with 128, drop to 32, drop to 8, drop to 2, drop to 0.5, drop to 0.125 or 125 thousandths, and then go to 0.03125. Once again, our equation will be in that form, and we would look at filling it in kind of the same way. Our initial value is the value of a. We would look here to identify that. When x is 0, what's the value of y? So we would know our initial value to fill in and to create an equation would be 8. Then we need to start looking at, instead of a growth factor, we would call this a decay factor because our numbers are getting smaller instead of larger. That's our value of b that we're looking for, and we would look somewhere where x increases by 1. What's the y value doing? First thing you might think of to go from 8 to 2 is you're dividing by 4. But I'd like you to remember in our equation we have an exponent there, which means repeated multiplication, not repeated division. So I need you to think of that division by 4 a little bit differently. And if we go back to thinking about what we do with fractions, to have 2/3 divided by 4, we kept it, changed it, and we flipped the 4, which was 4 over 1, to its reciprocal. And then division by 4 means exactly the same thing as multiplying by a fourth. So as long as we change the division by 4 to multiplying by 1/4, it would be the same mathematical operation, and that would allow us to end up having multiplication where we need it down here in our equation where we're raising it to the x power. So our equation would be y equals 8 times 1/4 to the x power. And it would be alright too if we change this 1/4 right here to the decimal form of it, which would be 0.25. Now, exponential growth and exponential decay are alike because they both involve what? It's a two-word thing here. I'd like you to try to fill that in on your own. The difference is that a growth factor is a value that is what compared to 1, while a decay factor is a value that is what than 1, and but it is still greater than what number here. So fill in those blanks in your notes. I'm not actually going to write them in, but I'll check to make sure that you have something written in as an attempt at doing that. We should check and make sure also, though, that our 1/4 worked all the way down the table. So every time x goes up 1, does y in fact go up by multiplying by 1/4? And yes, it does. So if we go on the back of your notes template, you have this, which was an additional tip. If you had to write an equation for this, you should notice it goes down. So it's either a linear relationship that is decreasing, but it goes down 10 here, and it does not go down 10 there, and it does not go down 10 anymore. The amount it's going down changes each time. So you should know it's going to be an exponential equation right now. You should not have much difficulty determining the initial value that goes here. So make sure you fill that in, please. To give you some support on how to fill in the other value, let's see what you should be doing as far as some thinking. Let's take a look. When we have x go up by 1, what is the y value doing? It's being multiplied by something here. So your thinking should be, and you could write this out, and please write it in on your notes template, your thinking would be that you have 40 times a number to equal 32. And how do you solve an equation like this? It would be to divide both sides by 40. So what you really need to do is you need to do 32 divided by 40 to find out what is the decay factor here. And the decay factor here, if you divide that, comes out to 0.8. Should help you with filling that in as well. Thanks for watching your video notes and taking them today. We will see you tomorrow in class.